Hello, welcome to our 2022 Capstone project presentation. My name is Takura, and together with Eddie, we will take you through our COVID-19 Model Hub project. We'll first discuss the goals that we set for the project, and we'll move on to the EDA and the models that we did. And lastly, we'll discuss some of the next steps and conclusions we found out. We had 4 main project goals. The first was some EDA on the data that we had. Secondly, we wanted to understand some of the models that are used to predict COVID-19 cases. And one of the key goals of this project was to build a repo of all the COVID-19 models that we could find. Lastly, we wanted to use these models that we could find to build an ensemble predictive model, which hopefully would have better predictions. From the EDA that we did at the country level, we saw that tests were evenly split between the private sector and public sector in terms of volumes. On the top right-hand side, we can see that there is a seasonal trend in the COVID-19 cases over time, which is as expected. On the bottom left, we can see that most of the cases just needed general wards, and a few needed intensive care and high care wards. And lastly, on the bottom right, we can see that there was a lag between cases and deaths, about a 3-week lag based on our data. At the provincial level, we can see that most cases were concentrated in Gauteng, Western Cape, and KZN. Deaths also followed a similar trend as expected. So we do need predictive models for decision-making, both in the public space and private space. Relying on one model is not flexible enough and robust enough for the highly dynamic environment within which COVID operates. So Ensemble provides an avenue to combine the predictive power of various models in order to improve your predictions. And we explore 2 main methods here, an arithmetic mean approach and a weighted average approach, which is better in terms of weighting the predictions of each model based on its predictive power. Eddie will now discuss the different modeling that we did.
Thanks, Takura. So before we've built the ensemble models, we have built 4 individual models, which is the first models that we have built was the basic CEDA models, which is the multiple state models, which take into account 5 stages of the disease. The second models that we have built was the modified CEDA models, which improve the basic CEDA models by incorporating the level of quarantine and also the level of lockdown. The third models that we have looked at was the generative models, which models the reproductive rate. The fourth models that we have looked at was the time series models, which model based on the seasonalities of the cases. The test period that we have looked at was between the 15 November 2021 up until the 15 January 2022, which was the latest wave that we had. We have also looked at 2 metrics that we have used to evaluate the performance of the model, which the first metric that we have looked at was the mean absolute error and also the root mean square error. The graph below show the visualization of the performance of the models. We can see like the ensemble models have the less error compared to the 4 models that we have built. And we can say the ensemble models outperform other models. The graph on the left, the blue line show the training data, and then at the top there we are seeing the evaluation period, which is the test period. And then on the right hand side, we can zoom in the testing period. The base models and the time series models, they underestimate the actual cases, and also the generative and the modified overestimate the actual cases. By combining those 4 models, you can see like we do have like a better models by a black line, which is closer to the actuals. We did identify 3 next steps, which we want to explore, which is including the best estimator ensemble approach, which is more robust. And we also wanted to add like more modules to the repo. And we also want to fully automate the process of retraining the model, refreshing the model, and also adding the model to the ensemble model.
Thank you, Eddie. So to conclude, we saw that COVID-19 cases are quite difficult to predict due to the many influencing factors. However, the ensemble approach is a very potent tool that one can use to tackle this challenge. Lastly, we saw that the Streamlit application that we deployed proved to be a very interactive platform which provided a lot of value. So thank you for listening to our presentation. You can contact us on these details. And again, thanks for listening.